room nicely.
What's wrong with it?
Anybody would like to say hello to Shannon?
Hi, Shannon. Hi.
All right.
What's wrong with it?
Okay, nothing is wrong with her. She just had a little surgery on her knee or her ankle. There we go, ankle.
Shannon, please clarify.
And so we're hoping she feels better soon and can come back and join us. All right, number 1. I'd probably use substitution. You could use whatever you want. I'm going to use substitution to solve it here. So substitute in for y, negative x plus 5. And so we get 5 equals 5. So my variables canceled, and I'm left with a true statement. Therefore, there are infinitely many solutions to question number 1. What would the graph look like?
The lines on top of each other.
A line on top of each other. Okay? Does anybody know what we call that?
Infinitely many.
Coinciding. When we have one line that falls right on top of another. Coinciding. But you know what? He's playing. At least, he's out there.
Who, me?
Yeah, Kyle. He tried. Matt just looked at you funny when you didn't answer out loud.
Thanks a lot,
I
man.
had your back, Kyle. I got you.
Thank you, Miss Willoughby.
All right. So, number 2. How do you want to solve this one?
Elimination.
Elimination, all right. So let's
Well, you can add 1 to the
we can
top
do a lot of
one,
things.
And then,
If we did this, or let's move this over here. And then we'll multiply 3 by negative 3, so we get negative 6x plus 3y equals 3. So we get 0 equals 6. Does 0 equal 6?
No.
Never.
Solution.
So when my variables cancel and I have a statement that is false, there is no solution. What would the graph look like?
2 parallel lines.
Yes, it would. A pair of parallel lines, therefore they never intersect. Any questions about number 1 or 2? All right, let's move on to 3. I could have made this one more interesting, but I copied it out of the book. So, Rosa bought 1 pound of cashews and 2 pounds of peanuts for $10 at the same store as Sabrina. And guys, have y'all ever seen a teacher use this, where you write words like, this is my
we
name,
used to do that in 6th grade.
and it'll turn it into, there we go.
Whoa.
Well, yeah, that's what I did here, and it thought my 1, it thought it was an I, and that's why I had to write over that. And then it just didn't capitalize Sabrina. I know I should capitalize Sabrina. Okay, so that's what happened there. Just a quick FYI. So Sabrina bought 2 pounds of cashews and 1 pound of peanuts for $11. Find the cost per pound of cashews and peanuts. So we need to write a system that represents this situation. If we let X be cashews, did you guys let X represent the amount of cashews?
I did C for cashews
Actually, cost of cashews per pound.
and a P for peanuts.
I'm all about that. Let's do C and P.
I like X and Y.
Just in case you were curious, I like almonds. All right, so 1 pound of cashews plus 2 pounds of peanuts equals $10. And then 2 pounds of cashews and 1 pound of peanuts equals $11. And then we solve. Pick your method. It doesn't matter. And what do we get? 3 and 4?
4 for C
Okay.
and 3 for P.
So cashews will run us $4 per pound, whereas peanuts only cost $3 per pound. I'm fond of peanuts, but you can't really eat those at school because too many allergies. Any questions?
Wait, I ate pistachios in school. Is that against the rules?
No.
I ate a lot of pistachios. I love them.
Okay.
I was doing good at school.
Huh? I mean, you can bring peanuts to school, but there are quite a few children that have allergies. So I have almonds. Not as many children are allergic to almonds. All right. Let's talk about homework now.
Like, honestly.
I corrected my graph to where it was tall enough. That's why mine's not tilted. So we set these up yesterday in class. We said X was tables and Y was chairs. And then we talked about how to graph a compound inequality, didn't we? So 0 is less than or equal to X is less than or equal to 20 is a vertical line at 0 and a vertical line at 20 and shade in between. 0 is less than or equal to y is less than or equal to 30 is a a horizontal line at 0 and a horizontal line at 30 and shade in between. So right now we're in this rectangle. Until we get to our last equation, which has to do with production hours. So when we graph that, we would connect from our intercepts, which we get by plugging in the zeros, 0, 48 with 32, 0, connect that. And this is less than, so we would shade below because 0, 0 makes this true. So this is my shaded region in here. And it's okay with me if that's the only thing you shade. What's the special name for a shaded region in a linear programming problem?
Solution area, something like that. It's like something that's
Feasible. Thank you, Donna. This is the feasible region. Excellent. Okay, that's our feasible region. Now, what we're looking at on our feasible region are the vertices of the feasible region. Now, yesterday we just called these test vertices, but some textbooks and some math teachers also call them corner points. So if we were to see a problem like this on an end of course test, I'm not sure if they'd call them test vertices or if they'll call them corner points. But does it make sense that you could call them corner points? Because they're at the corners of our feasible region. So we could call them corner points or test vertices. These are the ones for this particular problem. Looks like I'm missing one. Oh, I didn't write 0, 0, did I?
Wait, I have a question.
Is there any need to write 0, 0? No, because I'm trying to make a profit on this problem, and producing nothing gives me nothing. So really, didn't even need it. Yes, Matt?
What's the point, like, of even testing some of those, like...
I wouldn't. There's no point in testing, like, 0, 30 because this one's got to be bigger. There's really no point in testing this one because this has to be bigger.
Yeah,
So truly, there's only 2 that we have to try. I'm with you. I understand.
Thank you.
We do want to list them, though. So it shows we know what we're doing. But if you don't actually find values for those 2, I'm okay with that. Because you understand that the others must be larger. All right. And then when we plug these in, remember we plug them into our objective function, which this time our objective is to maximize our profit. So this function is 30x plus 40y. We plug those in. We get that the highest amount occurs when we produce 12 tables and 30 chairs. So in our complete sentence, we'll give the answer. The manufacturer should produce 12 tables and 30 chairs to make a maximum profit of $1,560. Did you say something like that?
Yep.
I'll be shocked if you use the exact same words, but something like that, and we're all good. Any questions? Let's move on. Number 2, take a look. Ask questions if you have them.
Oh, it's complicated.
Holy cow. I got it exactly right with you.
I got it right, but it's not what my graph looks like.
Did you make X tricycles and Y bicycles, or did you do the reverse?
I did that. Like that box is in the corner. It's not. And is your scale by like 10?
I'll check it.
Yeah, my scale's by 10.
I don't know what you did, Garrett.
Are we right?
Got the L in.
Or I think I know what you did. I don't know what you did. Oh, I know what you did, actually.
You want to
Do you think it? Did you do it?
So
Yes,
it's
it's
these at least 30.
It's quite obvious. I don't know why else, but I have a hole down there.
And the reason it didn't make a difference in this problem is because we're maximizing. So it's going to be these points right here that are the only one that would affect us anyway. If we're minimizing, then we would need these on the back end. But when you're maximizing, you want the bigger number. Okay, how are we doing? Oh, I sat down, I didn't need to.
I got bullet questions right. CBA.
Yeah, it's right there. That second show, make sure the fourth line is box.
Hey, Where's the like button? Look at elementary deviation.
Really distracting.
This is the
What happened?
Well, what happened? You got mad. He had something on his back and I was taking it off. And then he got mad. No, there's nothing in your bag. I took it off and put it in my mouth.
Okay. So I just passed out today's example along with the homework, which is on the back of today's example. So today we're going to look at a slightly different type of linear programming problem. Now yesterday our objective function was to maximize in every situation we looked at. Today we're going to look at some linear programming examples where the function is to minimize. So today's example, Marco is planning a snack of graham crackers and blueberry yogurt to provide at his school's track practice. Because he's concerned about the health and nutrition, he wants to make sure the snack contains no more than 720 calories and no more than 20 grams of fat. He also wants 20 grams of protein and at least 24% of the daily recommended value of iron. What's the chemical symbol for iron?
Fe.
Very good. The nutritional content of each food is listed in the table below. Each serving of yogurt costs 30 cents and each graham cracker costs 8 cents. What combination of graham crackers and blueberry yogurt should Marco provide to minimize cost? Okay, so we're minimizing cost this time. That's our objective function. So, should we have a profit equation here? No. Our objective function is to minimize cost. So we should have a cost equation. So if everybody would write that, then we can get going. So that question tells us what our variables are. The question said, what combination of servings of graham crackers and blueberry yogurt should Marco provide to minimize cost? So what are my variables?
Graham crackers and yogurt.
Graham crackers and servings of yogurt. So I'm going to let X represent graham crackers. That way I get to let Y represent yogurt.
Yogurt is my favorite. Yes.
Is it really?
Yeah, I love yogurt.
I enjoy yogurt, but
I don't like it.
I'm okay with yogurt.
if you gave me like M&M Blizzard or a yogurt, I might choose the Blizzard. I don't know.
I used to be that way, but then I got sick, and all I could eat was yogurt and ginger ale. So now I love yogurt and I love ginger ale.
When I was in the hospital, the only two things I could have were apple juice and Sprite. Otherwise, I'd throw up, and it was awesome.
Thanks for sharing.
I don't like the word yogurt.
Okay, so we're going to do our cost equation next. Now, the one thing, guys, the one thing students tell me about these problems is, it looks so simple when you do it.
Yeah.
And then when I sit down, that whole paragraph is just a little overwhelming, and I'm not real sure what to do. So, well, don't get overwhelmed. Go, all right, every time Miss Willoughby does it, she goes real slow, and she goes, okay, the question tells me my variables, so let's mark that down. And then let's get rid of our objective function, which we know in this case has to be cost. So what numbers up there had to do with cost?
8:30, 30, and 8.
8 cents for what?
Graham crackers.
Okay, 8 cents for graham crackers and 30 cents for yogurt. Now, if it makes you feel better, as you use numbers, mark them out. So you don't have to fret with them anymore. That one's gone. That one's gone. I used it.
That's smart.
I like that.
All right, for this problem, I gave you a table. Now, you don't need it, but it might help you to organize your data. Like on this one, I even put cost down at the bottom. Well, we've already done that. We know it's 8 cents for a graham cracker and 30 cents for a yogurt, and we know we want to minimize this. But it might help this other stuff. So when we read back through, what are the categories that deal with graham crackers and yogurt? Well, the categories are calories, fat, protein, and iron. Are those the things we read about in our paragraph that deal with my graham crackers and my yogurt? So these are the 4 constraints, other than the obvious, which are we can't have a negative number of graham crackers and we can't have a negative number of yogurts. Other than that, these are the categories that I read about in this paragraph. Well, tell me about calories for a graham cracker. What did it tell us about calories for a graham cracker?
60.
It looks like 60 right here, doesn't it? 60 calories for every graham cracker. And what did it tell me about calories for yogurt? 120 calories for each yogurt. And up here in my paragraph, it gave me a limiting value on calories. It says, my snack can contain no more than 720 calories. So wouldn't that be less than or equal to 720? So that first constraint I have deals with calories. And like I said, you don't have to have this chart. It might help you. It might not. So 60x plus 120y has to be less than or equal to 720. That's one of my constraints.
Wait, is the x's like whenever you always do the x is like greater than or equal to 0 on the y? Is that really necessary? Because whenever I do it, I never put that in it. Always seems like
I absolutely know what you're asking.
are these necessary?
Yes.
I was stretching.
Otherwise, it will keep going in a negative direction. If we
When
don't
you-
say that.
When you're doing the profit ones, is that necessary? Because when I went for the profit ones, I didn't do that, and it turned out fine for me.
Well, you do it. Because you only use the first quadrant.
Yeah.
But you got to say it so that you only use the first quadrant. You did it, you just didn't write it.
Yeah, but do we have to write that?
Yes.
Do we have? So we have
Once
to.
you get
upload?
used to it, yes. Yes.
Alright,
Yes.
Dad.
All right, next one, fat. Tell me about fat for a graham cracker. Fat for a graham cracker.
2 grams.
Okay, 2 grams for a graham cracker. And fat for a yogurt.
2 grams.
2 grams. And let's read back up. Oh, I'll use 720. Mark it out. No more than 20 grams of fat. There we go. No more than, which inequality is that? 20. Less than or equal to. So that second one has to do with fat. And it's 2x plus 2y must be less than or equal to 20. Now my third one. Your hint right here is protein. So if we come back up here and look at protein, we have 2 grams for each graham cracker, but we get 5 for a serving of yogurt. And our protein was worded a little differently. It says at least 20.
So it's greater than.
Greater than or equal to 20. So we get 2x plus 5y must be greater than or equal to 20. That's protein.
That's awesome.
And then the last one
Iron.
is iron. Well, I tried to write FE. That didn't work
I
out
don't
well.
understand why it's called FE.
It's probably Latin.
Yeah, I think it's Roman. I don't know. If you do AP Chem, you'll figure it out. Because you have to memorize all whatever. My brother used to do.
Mhm.
I'm just kind of a literal person, you know.
I get what you're saying, Kyle.
I get you. Why for what? Literal about life.
Are y'all done with iron? Okay, what is it?
Is it
4x
four?
plus
Yeah.
2y is greater than or equal to 24.
Yes, thank you, Kate. So we get 4x plus 2y is greater than or equal to 24. Okay, but it was percent, percent, percent. So if we multiplied through by 100, what would happen to all those percents?
Add 0.
We can drop them, can't we? So since every term had percent in it, we can really kind of pretend like they're not there.
Okay. Good question, though, Spencer.
No, it was great. We can even say this is percent of iron. There we go. Okay, now we have the important stuff. We've got our variables, we've got our cost, we've got our constraints. Now we need to graph. But in order to graph, we have to determine a nice counting scale for our graph. So let's come up here and let's look at what we're dealing with. Our first equation is 60x plus 120y is less than or equal to 720. So let's determine what the intercepts of that line would be. If I plug in 0 for x, it goes away, and y would be 6. If I plug in 0 for y, it goes away. And what's 72 divided by 6? 12. 12. Okay, why didn't I do 720 divided by 120? Because what happens to the zeros? They cancel. I just do 72 divided by 12 and 72 divided by 6. Okay, next one. 2x
It'd be 10 and 10.
plus 2y. Very good. Less than or equal to 20. You are correct. It is 10 and 10. X-intercept 10, y-intercept 10. Okay, the next one. 2x plus 5y greater than or equal to 20. What are my intercepts? X-intercept is
10 and
10. Y-intercept is 4. And finally, 4x plus 2y is greater than or equal to 24. X-intercept?
6.
6. Y-intercept? 12. We may count by ones. Please count off on your app. I'm actually going to just do every 2 and count, go 2, 4, 6, 8. I'm good with that. Make sure you label your axis. So X represents servings of graham crackers. And then Y represents servings of yogurt. Oh, and I came up with a clever title last period. You'll appreciate this. Track snacks.
Oh, I like it.
And it rhymes.
Almost, yeah.
It's called a slant rhyme.
Is it really? Or did you just make that up?
No, I
Slant.
swear on my left.
No, that's okay. That's okay.
Yeah, this one's cool.
Wait, but you don't.
I have a left pinky.
Oh, pinky.
I used to pinky swear. And what would I do if I lost my left pinky? I'd have to pinky swear with my right pinky.
Don't you? Are you
Does that
supposed to
really
pinky
count?
swear with
No.
the hand you write with?
Who does that?
Or with the right
Because
hand?
then you have the germs on your right pinky.
Can I remind you we are recording?
Sorry, Shannon.
All right, so let's go through and graph these. All right, let's look at the first 2. The first 2 are less than. So when I plug in my 0 zeros on the first 2, I'm going to shade towards the origin, aren't I? But the second 2 are greater thans. So Ryan, when I plug into the second 2, I'm going to shade away from my origin, aren't I? Which is going to make a more interesting graph this time. So let's do it. Let's see. Y-intercept of 6. X-intercept of 12. You can use your student ID.
I found mine, by the way. It was there the whole time.
Your
My
ruler,
hair is long.
or student ID.
I actually
Oh my God.
bought a ruler this time. I found it in the trash, and it's hot pink now.
Caleb, what does that actually look like? Oh, you don't have one? How did you not get one?
I have a permit. Do you have a permit? No. So something like oh, that's not well.
Not everyone gets it.
Okay, so both of these are less than. So right now we're down here in this bottom part. Now, because I'm going to have lots of lines, I'm probably not going to want to do the shading all the time. So I may just want to go, all right now I'm in between those 2. I'm just down here.
Actually, I want it.
Okay, you may catch up now.
Kate stole my ruler.
I found it in the trash.
Oh my goodness, mine. Maybe I watched it.
Oh crap.
That's not quite Willoughby World approved. Let me give you some alternatives. Goodness.
Nikes.
My teachers always
Fooey.
do that. They always give me alternative
Did you say cookie?
words.
I said goodness.
Especially if it's
And then he said cookie.
No, you
Crikey.
said cookie.
Say crikey.
I said fooey.
There's a guy on my soccer team named Cookie.
I would say food.
He's kind of an awkward child. No offense to Cookie,
Oh,
he's kind of an
gosh.
awkward child.
Okay, Josh, you're being recorded.
You can say crikey like yesterday.
All right. Does everybody have the first two?
I have.
All right, let's do the last two then. All right, these are greater than, so I'm going to shade above them. So I need an x-intercept at 10. I've already got one, and a y-intercept at 4. And I'm above this line. And then this is an x-intercept at 6. And a y-intercept at 12. And I'm also above this line. Now, it's not usually perfect on my Moby. It comes close, but it's not quite perfect. I do have a hand copy right here that I did, and I counted by a half just because I like it to be as large as it possibly can. So you can see clearly my corner points. Do yours look pretty clear?
Yeah.
Yeah, on the Moby it's a little clear, not great. All right, so we see the corner points of this feasible region. I'll try to color it in. So it's right in here. There's my feasible region right in there. All right. So if we look at those test vertices, I have 5, 2 is one of those test vertices, also known as corner points. I have 4, 4. I have 8, 2. And I have 10, 0. Are those the ones you have also?
Yes.
Okay. And where do we test our test vertices? Where do we plug them
cost
in?
Equation.
Into the cost equation, into our objective function, which is to minimize cost. So plug it in. Let's see what Marco should be paying per student for the track snack.
I'm not even going to test it. 0. I'm not even going to test it.
We don't have 0, 0.
No, 10, 0.
Oh. But you want to minimize.
Oh.
You better test it.
Oh, is that the answer?
Let's see.
What if it's the answer?
That would stink if you didn't test the answer, wouldn't it?
But it's probably not. Why are they
I don't think it makes sense. Tap that. Right, you do that? Test the verses. Straight garbage. I'll take it. No, stop, I want it.
I swear, if don't need to get these kids yogurt.
Miss Willoughby,
Yes, sir.
is our test gonna be are we gonna have a quiz before we have a test?
No. Unless I give you one of those fun pops.
Those were great. It really was. I mean, I did bad on it, but it's great.
It was fun.
You didn't do one on it?
Didn't do terrible. I didn't do well.
He got a 50.
A 50 wasn't a possible grade.
You got as close to 50 as you can.
All right, did you get that Marco could spend $1 per student if he gave them 5 graham crackers and 2 servings of yogurt? Or he could spend $1.52 per student if he did 4 and 4. Or he could spend $1.24 per student if he did 8 and 10. Or he could spend 80 cents per student.
But
If
why
you
would
just
he
did-
not give them yogurt?
But doesn't it have to meet
I would do the 4 and 4.
protein?
It does.
I do 10-0.
All the solutions in here, everything in this feasible region satisfies every one of our criteria. So, yes, yes, ma'am.
It says that what's combination of serving graham crackers and like serving both. So like.
So he would do 10 servings of graham crackers,
No, he shouldn't. No, he said Marco should.
and 0
Not
servings
should
of
provide.
yogurt
That'd be bad.
for a minimal cost of 80 cents per student.
Miss Willoughby, I get where you're coming from, and I understand you only want to spend 80 cents. But the kids are going to be sad when they don't see any yogurt there.
Marco didn't say anything about whether they're happy or sad. He
Oh.
really
What he
doesn't
said, he
care.
said
Oh. But we knew what you were doing.
servings of both
Yeah.
of them.
He's
But
saying-
now look,
Serving
look.
both of them.
You're serving 10 of one and 0 of the other.
I understand.
0 is another.
Serving one of them.
I understand this is a math equation, but
I'm with you.
I'm here for the justice of children and math equations.
Okay. So there we go. And we answered it in a complete sentence, didn't we?
Yes, ma'am.
Excellent.
we did.
All right. So you have 2 to practice for homework. I want to talk about one thing before you go to practice.
Oh. Math practice.
You know there's a math website that gives you all the answers?
To all of my questions.
You just have to type in the question and it gives you the answer. I've never used it, but I saw it on Twitter.
There's a couple places that you can go and put in your question and they will give you the answer. A lot of the worksheets I give you, I wrote the problems. Like you're going to flip it over and you're going to go, Auburn and Georgia Tech cattle food? Yeah. Who's a Tech fan? Me.
You.
And you two guys.
He likes Georgia. But I want to go.
In this class, he's a Tech
Well,
fan.
I want to go to Georgia Tech.
There you go.
Kate's got a Georgia shirt.
All right, so here we go. Let's say we had a minimized problem, such as the ones we're working on, but everything was greater than. So if this was one of my inequalities and this was the other, and everything was greater than, where would I shade?
It would be that bottom triangle.
Out here, if it was all greater than. Well, this goes forever, doesn't it? There's no stopping it over here. This is called an unbounded region. An unbounded region. This is only going to happen for us when we have a minimized problem.
So we're going to have one of those?
More than likely. Because we can use these vertices, which are the corner points,
But you have all those different solutions.
because we want to minimize, one of these will be our answer. If the question was maximized, this isn't going to work for us. Because
You
we
can't
don't
find
have
the
any
biggest
points
one
out.
because-
Right. It goes on forever.
And ever.
So, we're only going to see an unbounded region in a minimized problem.
Never
Okay?
ever in a normal problem.
All right. So what I want you to do is I want you to flip over and start your homework. Do not get overwhelmed by the paragraph. Little bit by little bit. Identify variables. Make your cost to profit equation. Mark those numbers out as you go. See what's repeated over and over and over again. Those are your categories for your inequalities. Those are your constraints. And my answer key is on the overhead for you to check your progress. If you just want to know, am I right? Look here. Okay?
I'll just verify that we